welcome all my dear students. In this lecture 10, we are going to see the implementation of linked list in the programming language C. Because most of us are familiar with the programming language of C, so I am going to show this example with the help of C language, and I'm going to show you in this lecture how we can convert an algorithm which we have seen already of insertion and deletion in case of a single linked list to a C program. So let's start it. So let us start programming. In this example, what I'm going to show you is how to implement the insertion and the deletion in a single linked list at the end. So I'm going to show you insertion and deletion of a node in a single linked list at the end. Now, for this, you can do one thing. You can refer to my previous slide on a single linked list. If you haven't copied down the algorithm for that, you can copy it down and then you can just match what the steps what I am writing along with the algorithm which I have discussed. I'm using an online editor here. So you can install any kind of C software like C++, or you can use a GCC compiler. And irrespective of the compiler what you are using, this program will be running in all the compilers. So let me start with it. Now we know that hash include stdio.h is the common file, header file used in any kind of C programming language because of the basic functions like printf, scanf, etc. And along with that, I am going to include one more file here, header file, which is known as stdlib.h. So this function is basically used for, if you remember, I told that in case of a linked list, the memory is allocated dynamically. And because of that, memory is done dynamically, so we have to use the malloc and calloc function. So this header file is used for dynamic memory functions such as malloc and malloc, calloc, and free. Free is also a dynamic memory allocation function which frees up the memory space which we are using. So this we have used in our deletion algorithm. If you remember what we have written, free PTR. Now I will be writing down the basic thing, that is if we want to declare a linked list node, what we use a structure. We write node. So this node name can be anything. I have given node, you can do anything. I'm going to create an integer linked list. So it is going to store an integer data. And because I'm going to create a single linked list, so it will contain a node star next. So there will only be a one pointer, which is the next pointer. Now, we have defined the structure. Now let me define. Now in case of a linked list, we are going to create some global variables. The first global variable will be struct node star start. So if you remember, we have a pointer which was known as start. So we have this pointer which was known as a start, and this was going to point to the first node in the linked list. Now, because this is a pointer to the linked list node, so this must also be of the type struct node start start. So that's why start is a pointer of the struct node type. Along with that, we are going to use some functions. The first function is the insertion. So I'm doing an insertion at the end. You can do it for any insertion at the beginning, insertion in the middle. I'm showing you one algorithm and the others will follow this. So if you understand how to convert the algorithm of the insertion and deletion algorithm at the end to a programming language, you can do the remaining also by understanding the algorithm and converting it to a programming language. So this insertion algorithm, let me name in. That means I want to insert at the end. And if you remember that in case of the insertion algorithm, there was any kind of insertion algorithms were having two inputs. So the two inputs were specifically, one was the list and the value val which we want to insert. So because we are going to do this, so we have to put an argument to this insertion function will be a integer type of data which we want to insert into our linked list. So that's why it will be here. It will be here int val. Now when I am creating the chart, I will be initializing with null because initially when there was nothing in the linked list, start is pointing to a null value. It indicates that start is pointing to an empty list. The list hasn't been created yet. Now we have to create a new node. So if we have to create a new node, then what we have to do, we have to define a node with the type this. So again, new is a node. New is the name of the node of the struct node type. So it will be containing two parts. One is the data part and one is the pointer part. So let me draw that here. So this is going to be my new node. I haven't created it yet because I have not used any kind of dynamic memory allocation scheme here. Now I'm going to use it. So what I will be writing here? So I will be writing here new struct node start malloc. I'm using the malloc function. You can use calloc also here. Size of struct node. So here we are using the malloc function if we are giving the size of struct node. Now this is going to create a new node. So this line is going to create a new node for my linked list. Next, now all the insertion algorithms were having a common line to check whether the node which has been created is created correctly or not. So how to ensure that? So if avel was equals to none. Now here we are not doing that avel equals to none. Instead what we are doing, we are checking for the new is equals to null or not. That means after allocating, after dynamically allocating a memory space for a new node, we are checking whether actually that space has been allocated or not. If it is null, that means there is no available space in the OS and the new pointer or this new pointer has been given a null address. That means it has not been allocated in a space. So we have to check this condition. So if this is the case, we write printf overflow condition. So it's an overflow and we return. So when you write a return statement here, it means that it will not go through the remaining lines of code. It will simply come out of the loop. Now, if this is not the case, then what happens? So we will be following the next line of codes, that is new arrow data. So new is my new node. So in the data part of it, I will put the value val, and we will stop here because this is we will do one more thing, because this is going to be the last node in my this list. So naturally new arrow next will be equals to null. So we can do this safely. If you look at the algorithm of insertion at the end, so these two steps you can easily do. Because this is a last node, we put a null value. So let me put a value here. Let me put a value of 10 here. I want to insert 10 here. The value is not of much importance, rather the pointer part is important. Now let us look at our diagram. So I have created the new node and this was my S, which was now null. What do you have to do? When I am trying to insert at the end, what we have assumed when I was going through the algorithms, that a list already exists. What happens if the list doesn't exist? That means you are trying to create the linked list. You are trying to create a linked list with the first node. So in that case, we have to check this, that if start pointer is equals to null, that means the list is empty. There is nothing in the list right now. So we simply write start equals to new. That is, we are making this start point to the new node. So we are going to do this. That means this is my new node and start is going to point to this. Once this is done, that means now my linked list has at least one node, which is 10. So what you can do is that you can either include this line. Okay, then we are going to return again, because why we are going to return? Because this is the first node, start has been assigned to or has been assigned to point to this node, and we can return because the other steps need not be done. This is the first node. If this is not the case, then what we have to do? We have to set a pointer which will, okay, we have to set a pointer which will be pointing to this node, and that node we can write as PTR as we have seen. So we can write this node pointer to be PTR. So if you look at this program, so we have to create another pointer of PTR. Now why the type of this pointer PTR is struct node? Because PTR is going to point to a node which is of type struct node. So we know the definition of a pointer, that the data type of a pointer will be the same to which it wants to point. So if it wants to point to an integer data, the data type of the pointer will be int. If it has to point to a float data, the data type will be float, and so on. So here we want to point to a data which is of type struct node. So it will be of type struct node. The second thing is that this part you can either include in every insertion algorithm which you write, or you can make a separate function maybe called create, and a separate function create may be used for creating the first node in the linked list. So remember students, program can be written in a multiple number of ways. It is up to the programmer who is programming. But the basic steps which we have seen in case of algorithm will be same. Basic steps for the insertion of a node at the end of the linked list will be same. These are few things which you can either do it before, or you can create a separate function and do, or you can include this line in every insertion algorithm. Now what we have to do, suppose by using this algorithm, I create another node and I put the value 20 there. Now what I have to do, I have to insert this element at the end. So first time when I run, initially the list was empty. So this particular part will be called, and I have created the first node. Now when the second 10 you are going to insert, so this value 20 will be inserted after 10 at the last. So at that time what we have to do, so we have to make use of that PTR. So here PTR will be equals to start. So we make a pointer point to this node because we have to reach the last of the node. And how can we reach it? We can make while PTR arrow next is not equals to null. That means when the PTR arrow next part is not equals to null, we have to keep on continuing the PTR. We have to keep on taking the PTR to the next node. When this part, the next pointer part of PTR becomes null, that means we have reached the last node. So if this is not the case, what we have to do, PTR equals to PTR arrow next. So once we reach the last node, what we have to do, so in this case, this is my last node. What we have to do, I have to put in PTR arrow next part. So in this part of PTR should be the new node. So it will be equals to new, and we have already made PTR, we have already made this part to be null. So through this line, we have already made this part null. And what we do, by this line, we have done this. So this linking is over. So now this point, this node has been included at the end of the list. So our insertion is over. So our insertion is over. So if you match this program with the algorithm, you can see that there are few steps which has not been mentioned in the algorithm, like creation of this new node, and the other is this start equals to null. Now that's why I told at the beginning of my lecture on linked list that linked list is an abstract data type. So when we write the algorithm and the way we implement it, so there are some hidden facts. When we write the algorithm, we don't reveal everything of how to implement a linked list. When we program it, then only these factors are taken into consideration. That's why we call linked list to be of an abstract data type. So my algorithm on insertion at the end is over. Now I am going to write the algorithm for deletion at the end, and let my algorithm name be delete at the end. And for the deletion algorithm, there was only the list. So let me start again. Again, what I have to do, I have to, now for this part, we need not create anything. I will just leave that part empty. We will come back and see what happens. So the first checking which we do is if start is equals to null. That means if the list is empty, there is nothing to be deleted. What we write printf. It's an underflow condition. That means the list doesn't contain anything to be deleted. So we write underflow we return. That means we return from this particular function because to the main calling function, because the other steps need not be executed. So I will just remove this part. Next. Now suppose I am left with only one node in this linked list. So one is if nothing is there. So one is like this when nothing is there. So this is this condition if start is equals to none. If the situation is not like this, if it is like this, so this is not null. Rather, this is pointing to a node like this. When I run this program, for the time being, I am keeping this part in a command. I am keeping it commented. We will see why this is needed. So what I mean, start is pointing to the node, that is the first node. Only one node is left in the linked list and the next part of that start is empty. So what we are basically checking, if start arrow next is equals to null. That means this is the only node left in my list. And as I told you, I'm going to comment this part. I'm going to show you why this part is necessary when I execute the program for you. Okay. Now, so what happens if start arrow next is equals to null? That means that start is going to point, so we are going to delete this node. If we delete this node, then start have to point to a null because that value will no longer exist. This node, if this node doesn't exist, that means start have to point to a null value. So what we do in that case, we free start. We free start. That means we are free. Again, you see, free is a dynamic memory allocation algorithm, is a function which we use for deallocating the memory space reserved for a pointer. So for that we use the free function. So we write free start and then what we do, we write explicitly start is equals to null. That means now if we delete this node, so if this node is deleted, then start was pointing to an address. So if, let us think of this like this, let the address of this node be 200. Let this address be 200. So what was there in start? Start was having the value 200. Now, if we delete this node, so if we delete this node, that means this memory space 200 is deallocated. But what does start actually contain? It still holds on to the value 200, which is no longer existing. Start was initially pointing to address 200. That's not, that address has been deallocated. Now start is still pointing to a location which is not there, which doesn't exist. So if this kind of scenario exists, we get a runtime error. I will show you that when I run the program. So that's why it is necessary for this line, it is necessary to make start equals to null. And then we return. That means the remaining lines of code need not be executed. And we uncomment. That means this part is necessary because when you know this is known as a dangling pointer problem. When a pointer points to a memory location which no longer exists, it is a dangling pointer problem, and in that kind of scenario, if you try to access that or if you try to use that, it creates a runtime error. Now, if this is not the scenario, then what happens? If it is a normal case, so suppose we have a case like this. Instead, we have a 2 pointer case, 2 nodes case. So this is 10. And this is 20. And I'm doing a deletion at the end. That means I want to delete this node 20. So if I want to delete this node 20, what I have to do? I have to start from this starting node, the first node, and reach the end. And for that, we have to use a separate pointer which is known as PTR. So we have to create a temporary pointer which is PTR. That's why I have kept this space empty, because here I want to create a node, a pointer of type struct node. That's why I kept this place empty. So this is for the temporary pointer. So what it will be doing, it will be assigned to the start address. So it starts from the first location. We have to reach the end. So we will be checking for this PTR, like the insertion algorithm, PTR arrow next, whether it is equals to null or not. And if you remember, in case of the deletion algorithm, we were actually using 2 kinds of pointers. So one was holding on to the node which we want to delete, and one was holding on to the previous node. So I will just complete this line first. So we have to go to the last node. So it will be PTR equals to PTR arrow next. So this is, but if you see the algorithm, we were actually using 2 pointers, which was one which was holding on to the node which we have to delete, and the other which was pointing to the previous node. So we have to create one more node here, which is known as pre-PTR or PPTR, we can tell. So PPTR will also be pointing to this node. So PPTR will also be pointing to this node. And then if this is not the last node, what happens? PPTR remains here, but PTR moves to the next node. So PTR moves to this node. Why this is necessary? Let me see. Because why PPTR we have to do? Because when we delete this node becomes the last node. So PPTR basically takes care of the node which is going to become the last node after deletion of the present node. So that's why PPTR, or there are requirement of 2 pointers. So what we do? So PPTR basically is equals to the PTR, that is the present node, and PTR moves to the next node. Now when we do this, what happens? We free PTR. So PTR is memory space is deallocated, and then this node, so we have deleted this node now. So this node doesn't exist anymore. We have free PTR. Now what happens to which node now will be the last node? The node which is pointed by PPTR. The node which is pointed by PPTR will be the last node now. So what we can write? PPTR arrow next is equals to null. So that ends my deletion algorithm. So my node has been deleted and this becomes the new node, last node. So this is the end. So if you see the algorithm and the way we are writing the program, there is not much difference in it, except for few added lines, which is required for converting a given pseudocode to a program code. And now what I want to do next, I want to display. I want to display after inserting, I want to display the whole list. After deletion, I want to display the whole list. So for display, again, what will be the input? Only the given list will be the input. And then again, I have to create, so I have to start from the starting node and go till the last node. So again, I have to create a temporary pointer. And then the first thing which I have to do is that whether there is anything in the list or not, like in case of deletion. So first I have to check whether there is anything in the list or not. So if start is null, that means I can safely write there is nothing to display. The list is empty, or we can also write the list is empty. Because if the list is empty, then only PTR, that is chart, will be null. And we can return, that is we can go back to the calling function. Else what we do, same like moving from the first node to the last. So we can write like this, PTR equals to start. And now while PTR is not equals to null. Now here we are not checking for the next part. Why? Let me check. Let me remove this part. Let me create one more node here so that we can easily, I can easily demonstrate you why it is, what it is actually going to do. So my PTR is equals to start. That means PTR is pointing to this node. So my PTR is here. Is it equals to null? Is it equals to null? It is not equals to null. So what I write? I want to print that value which is there. So I write printf okay. Now one more thing I'm going to do here. I want to print like the value at node 1. So I write int I equals to 0. So this is going to give me the count of nodes also. And here I first increment I, because when PTR is not equals to null, see in this case, so I am at the first node. So if I am at the first node means I should be 1. So this gives me the first node. So I can write like the first node has value. So I, comma, PTR, arrow, data. And then what I do, I go to the next node. So PTR equals to PTR, arrow, next. So let me come here. So my PTR is what it will be first displayed in my example. So first 10 will be displayed. Again, I do a PTR equals to PTR arrow next. So now PTR will move to this node. So it is PTR. Now when it moves to this node, is it equals to null? No, so I value becomes 2. And then the node which is printed will be, so here at first I value is 1 and then it is 2. And here first it will be printing me 10 and then it will be printing me 20. And then it becomes PTR equals to PTR arrow next. Now when it becomes PTR equals to PTR arrow next here, then the PTR value becomes null. Because PTR equals to PTR arrow next is null. So now it becomes null. So once it becomes null, it will not enter anymore here. So it will come out. So then what I can write? I can simply close my program. So I can simply end my program. So this is the display part. So it is simple. It is very simple. It is like traversing the whole string, whole list. So we are starting from the first node and we are traversing the whole list to display what is the content of the list. Now we have written the program for insertion at the end, deletion at the end, and the display. Now we will be writing the main function. So what we have to do in the main function, now here we have to first create val. So this will be the value which we want to insert into my linked list. Now remember, when I want to insert a value, I can do it in multiple ways. You can either take the input in the main and pass that as an argument to the insert function like what we are doing here. Or you may take this as the input in the function itself. So it depends on the implementation programmer who is going to do the implementation. And one more we are going to have, that is the choice. That is, we are going to ask the programmer which operation on the linked list he or she wants to do. Whether they want to insert, whether they want to delete, or whether they want to display. So what we do, we first print if. So we are asking the user to give his or her choice. So enter. So 1 is insert option, 2 is delete, 3 is my display, or you can also write traverse because we are traversing. So I may change this function name to traverse. Or we can also write, because traverse and display works same, so we can write any of the following. So traversal, we can write traverse. And we can write last option, exit. Exit will exit the program completely. Once we do it, now we are asking the programmer or the user to give his or her choice. So enter choice. Going to take the choice from the program, from the user. Now we are going to implement that. What we are going to write? We are going to write like this. So we are going to run an infinite loop, for loop. Now this part, this choice you can take in multiple ways. You can either do what I am doing. Instead of for, you can also use a while loop, or you can use a do while loop, where the first time all the statements will be done, the options will be taken, and from the second one, it will depend on your choice value. Or you can also use a switch case for it. So this is completely dependent on the programmer who is going to do how he wants to take this choice from the user. So I do it in a very simple way. So I write if I can take this choice inside also, because this is going to run repeatedly until we press 4. So I've taken the choice, and then this is going to run again and again and again. So until we give a 4 when we exit the program. So now I write if choice is equals to 1. Then what we do, choice 1 is for the insert. So in this case, we have to take the input value from the user. So enter the data to be inserted. So we are going to take the value which we want to insert, ampersand val. Now again I am telling, if you are going to take this as input from the user in the insertion function itself, then you need not do this, because we are passing it from the main as an argument to the insertion function. So we are writing it in the main. My next choice is deletion. So if choice is equals to 2, then what I will be doing, I will be deleting from the end. Deletion will have no arguments. My choice 3 will be traverse. So again, you can either write traverse or you can write display. Both basically do the same thing. So you are traversing and displaying. My last option is exit. That means if I press 4, I should exit the program. So here you can either use the exit function, or we can also use a break. Break will take the control out of the for loop. If I have anything other than this 4 options, then it will prompt the user to put the correct option. Enter a correct choice. That means I have put a wrong choice other than 1, 2, 3, and 4. So once this is over, I can end my program. So there is nothing much to be written after this. So this process will keep on continuing until we press a wrong choice. So that's why I told we can either put break here, which will take the control out of the for loop, or we can also use the exit function, exit 0. So you can either use any one of the following. Now it is my time to compile this program and check whether there is any error or not. So I run the program, and what I see, my program has run completely correctly. So there is no error in my program. So at first, let me check give delete 2. So what is the situation now? Now the situation is something like this. So I have a start node, and that start is equals to null, because in my linked list there is nothing. So now if I press a 2 here, so if I press a 2 here, what it should give me? It should give me an underflow condition, because S is null, that is there is nothing in the list to be deleted. Similarly, if I give a 3 option here, it is not going to show me anything, so there is nothing to display, the list is empty. Now what I do, I first insert. Now when I am creating the first node, at that time my list is empty, there is nothing in my list. So then that step will be called, whereas then start will be assigned to the new node. So I enter the value 10. Now I enter the choice 3. We see the node 1 has value 10. So now this is no more empty. S is no more empty. We have created a new node here. So this is my new node with the value 10. Null has been assigned here through our program, and this link is over. Next, again I give a choice. Again I want to insert data into this. So I write 1. I enter the value to be inserted to be 10. Again I give an option 3 to display. So my 2 nodes are there. The first node is having value 10, that other is 20. So remember, the display always works in the forward direction. So the first node which you are doing, so we move in this direction for traversing. So the first node value which we have inserted was 10. The other node value is 20. And this is 9. Now what I want to do, I want to delete data from my linked list, but the deletion will take place at the end. So I enter a choice 2. Now I give the option 3. So the node 1 has value 10. So this node has been deleted. So we are having two nodes, 10 and 20. I have entered the choice 2. That means I have deleted a data. Now it has only 1. So this part is no more there. Now see this scenario. In this scenario, what is happening? We have only one node in my linked list. So again, I give it to be 2. I press enter. We see an error here. So I will just underline that part. See, segmentation fault, code dumped. So you can see here, the error is segmentation fault, code dumped. So this was the error I was talking about when I was writing the code, that if this node is deleted, this node is in fact deleted. We delete this node, but what happens if this node is deleted? So if the address of this node is 200, so we free up this. So if we free this node, we have freed this node, but still this particular start node is pointing to the address 200. So the node is not there, but it is still pointing to 200. That means it is pointing to a memory location which has been deallocated. So this is the problem of the dangling pointer. So for this particular case, what we need to do is that we need to include that line. So that line in the deletion part, which I have commented before, that if start arrow next is equals to null, then we first free start. We are not freeing the node, but we are rather freeing the start. That means whatever address start was pointing to, we first free that, and then we make start equals to null. So this step is necessary for the dangling pointer case. So let us rerun the program. So again, let us do the same thing. So we have entered 1. Data we have inserted 10. Again, we have entered choice 1. Again, we have entered the data 20. Now I have entered the choice 3 so that we can see what are the values here. Now I have entered the choice 2, so I want to delete at the end. So let us see. Yes, the node has, because the last value 20 has been deleted. Again, I give an option 2. Again, I give a 3. See, there is nothing to display. So my 2 nodes values which was there has been deleted successfully. And I have entered the choice 3 and there is nothing to display in the list. So the list is empty. Now suppose I enter a choice 6. So I have entered a choice 6. So what it is going to tell me, enter a correct choice. Now I give up 4. So it exits the program. So this is the implementation of a single linked list insertion and deletion and traversal. Insertion and deletion algorithm from the end and the traversal algorithm. The reason why I have shown you this is that if you take up and if you compare it with the algorithm which I have already discussed with you, it is just a copy paste of that algorithm with few modifications. So whenever you are writing a program, make sure you have a pencil and a pen with you. First you draw the linked list, not for linked list, but this is applicable for any kind of programming which you want to do from a given algorithm. First you do that algorithm with your hand and you can check what is going to be the consequence of each step. You run the program, you write the code, you run the program and see what error it is given, and based on that you can modify the code. Because remember that this particular step we haven't mentioned in case of our algorithm explicitly. This situation arises only when we start writing the code, because there is a dangling pointer case arising out of that. So that's why whenever you are having an algorithm, you convert that to a program, you may have to add few lines here and there, and that you will be learning once you start doing the programs on your own. Here I have discussed the single linked list. In the same way, you can also do double linked list algorithms, circular linked list algorithms, and the single linked list other algorithms. I hope this video is helpful to you. In case you are having any doubt in any of the algorithms and writing the code, you can always comment in the comment section, and then we can discuss that in any of the coming lectures. Thank you very much.